I want to welcome you to another statistical topic. And of course, today, the focus is going to be on p-values. Today's topic is of high significance to the statistical world and even to the world of research in general. Of course, when you come across any research article or where statistical technique is used, you're actually going to see that they report p-values. So today, I'm going to walk you through uh, the mathematics behind p-values, what we use p-value to do, okay, and among other stuff. I'm actually, going to walk you through that today. Now, let me first, before I move forward, I first want to have a kind of recap on what we've done. I remember I introduced you to hypothesis testing. Of course, hypothesis testing is a way of testing an hypothetical statement about the value of a parameter. Of course, parameter could be population mean, could be population proportion, could be difference of proportions, could be variance, and so on, like that. And of course, I remember I told you because um, we needed to take a statistical decision. Taking a statistical decision, we believe we live in a stochastic world. There is an uncertainty and there is high tendency that we're actually going to commit error. And that was why I walk you through two types of error in hypothesis testing, the type 1 and type 2 error. Of course, what we want to do today, one of the roles of p-value, in addition to enable us to have a common ground in taking a decision, it can also be used as a measure of type 1 error. But let me first remind you the significance of type 1 error and the type 2 error. I remember the other time I said the type 1 error is when it's committed when the non-hypothesis is rejected when it is true. How do I know it is true? You may not be able to know it is true during your research, but the nature knows the truth. There's always going to be truth somewhere. Does that make sense? So we want to assume that if HO is true, okay, and that HO is being rejected, we've committed type 1 error. And of course, the type 2 error, on the other hand, is accepting the non-hypothesis when it is false. And of course, I remember the other time I said, which one is worse or which one is more serious between type 1 and type 2? I know statistician is going to say type 1 error. Of course, I said something the other time, either could be serious depending on your research content. I'm going to first cite an example in a medical world, in a judicial system. Okay, now let's take a look at this. United States use a jury system, and I want to believe an accused person is presumed innocent unless it's otherwise proven before the court. The non-hypothesis is, let's say the non-hypothesis is innocent, right? Alternative is guilty. If the null hypothesis is rejected, and if the nature have it that that null hypothesis is true, because the nature always know the truth, even though we are searching for the truth, but the nature knows the truth. Now, it means an innocent person will go to jail. That's a type 1 error. And of course, if because of the evidence before the court, if somebody who committed the offense by nature committed this offense is being discharged and acquitted, then it means they fail to reject. It means what has happened here, this guy committed the offense, but they accept the non-hypothesis, and that person is actually going to be discharged and acquitted. And that was why at times I say criminals live around us. But in a judicial system like the United States that use a jury system, the one that is more serious is type 1. Because they don't want an innocent person to go to jail. They want to prevent that. Okay. Of course, they believe that if type 2 error is committed, and if somebody who committed the offense is now being freed, he cannot run away forever, the law is still going to catch up with the person. Now, what about in a medical diagnosis? You have a mild symptoms, you have a symptoms, and you get tested for COVID. Okay. Let's say the disease is not present, but because of the fact that equipment is not 100% efficient, and the machine say, oh, the COVID is present, that's a false positive, right? Imagine the trauma that person is going to have. Oh, I got this disease, and the person doesn't have it. Okay. And the type 2 error is going to be the person have the disease, but the machine actually say, no, it doesn't have this. That's a false negative. Okay. And the person is being released to the society. What if that disease is infectious? What is going to happen? It's going to infect every other people. In that regard, type 2 error may look more serious. Does that make sense? But the two, depending, one is going to cause a psychological trauma to the person who do not have it. Okay. When they say the person have it, and there's going to be a waste of resources, committed to treat the person. But let me tell you this, whether type 1 or type 2 error, I said it the other time, we need to minimize the two. And we realize if you focus on one, if you minimize one, then the other one is going to go up. And I demonstrated in this class. The only way we can actually minimize the two is to consider increasing the sample size. And I remember what we did in the last class. If you have a desired type 1 and type 2 error, we have a formula to determine the minimum sample size required. Okay, now today, p-value is an alternative way of taking statistical decision. If you are testing hypothesis, whether the non or the alternative hypothesis, what do we normally do? We normally consider whether the test statistic falls in the rejection region. It's either the test statistic fall in the rejection region or it does not fall in the rejection region. If the test statistic fall in the rejection region, of course, you're going to reject the non-hypothesis. It doesn't fall. Actually, you're going to fail to reject that. And of course, what we've done before is to determine what is the maximum probability of committing type 1 error. The maximum probability of committing type 1 error is actually what we call the level of significance, which we denoted as alpha. And of course, Of course, I walked you through this before, which is a probability that the test statistics we actually lies in the rejection region, given the non-hypothesis is true. Let me tell you this. It is so unfortunate that somebody can go to jail even though the person did not commit the offense. And that is one of the reasons why I normally want to avoid going to court, even if I have a very good evidence, because the judge could make a mistake. The judge lives in a stochastic world. Now, we actually, if I set my alpha to be 5%, you know what I mean? It means the possibility of that happening, it will happen 5 times out of 100. But what we normally want to do, when we set the level of alpha, we don't want a situation where that will be exceeded. I'm going to say that again. We don't want a situation where the type 1 error rate will be exceeded. Does that make sense? The moment we made up your mind and say, okay, this is the level of significance that I want. Okay, now, when you take a look at this example on the board, you know, we did something like that before, you are actually testing. This is a two-sided test where you're actually comparing two groups, and the non-hypothesis is trying to say there is no significant difference between the two groups, between the mean of the two groups. And the alternative is saying there is a significant difference. I need you to take note of this. Whether the non-hypothesis or the alternative different exists. I'm going to say that again. Whether the HO or HA different exists in life, there's variation. But in the HO, we're trying to say the difference that exists is due to chance. It's not significant. While the alternative is going to say the difference that exists is significant. Does that make sense? And of course, if you want to do something like that based on what we've actually done before, of course, we're going to have a test statistic for that. And the moment we actually have a test statistic, what we're going to do is to get a rejection region. I've shown you this before. That's a rejection region. The rejection region is going to be the absolute value of Z greater than Z alpha over 2. We're actually using Z alpha over 2 because you're talking about two-sided tests. Okay, now take a look at this. We actually compute our Z statistic to be negative 2.5, and we actually need to be able to take a decision given level of significance. Don't forget, the level of significance is what we call the level of statistical error. It's also called the maximum probability of committing type 1 error. Now, at 5%, I will need to check. I will need to get my Z alpha over 2. At 5% is 1.96. At 0.02, like 2% is 2.33. And at 1% is 2.58. I need you to first take a look at that. When the level of significance is decreasing, what happened to the Z-score? The Z-score is going up. I needed to take a look at that. Take a look at the level of significance from 5% to 2% to 1%. That is in decreasing order, right? What happened to the Z-score? The Z-score is actually going to be increasing. And let me tell you this. When the level of significance is 5%, if you want to go by way of confidence interval, that would be 95% confidence. If the level of significance is 2%, then the level of confidence will be 98%. Which means, on the other hand, when the level of significance is decreasing, the level of confidence is increasing. When the level of confidence is increasing, the z-score is actually going to be increasing. Now, don't forget, because we're talking about two-state tests, the test statistic value, we're going to find the absolute value of that, which means we want the results, we don't want it in negative. Now, because 2.5, if you look at 0.05, 2.5 is greater than 1.96, 2.5 is greater than 2.33, but 2.5 is less than 2.58. And of course, when the the test statistic value, the absolute value of that is greater than the critical value, you're actually going to reject H naught. Now, I need you to take a look at what you're seeing here. What you're actually seeing here is we take different statistical decision using different level of significance. You can see we got different decision taking. Okay, we at 5% and 2%, the non-hypothesis is rejected. Okay, the non-hypothesis rejected here means there is a significant difference. But at 1%, is 99 confidence level, we fail to reject that. Okay, so that is a graphical representation of that. And of course, the takeaway here, when the level of significance goes down, okay, when the level of significance go down, the evidence needed for rejection goes up. Does that make sense? So which means depending on what your value of alpha is, we could reject or fail to reject. Does that make sense? So what determines the decision to be taken is the level of alpha. Now, if the level of alpha is what determines that, now, if I don't want to take the decision comparing the test statistic with the critical value, what is the alternative way to take a decision? The alternative way to take a decision is to make use of a p-value. I think I just discussed one way of taking decision now, comparing the test statistic with a critical value at any given level of significance. But an alternative way, okay, to take a statistical decision is to make use of the p-value. Now, let me tell you this. What do I mean by p-value? P-value is the probability of observing an extreme value when the non-hypothesis is true. I'm going to say that again. P-value is the probability of observing an extreme value when the non-hypothesis is true. Okay, and let me tell you this. The lower the p-value, the lower the chance of committing type 1 error. I'm going to say that again. The lower the p-value, the lower the chance of committing type 1 error. Now, if you take a look at the definition now, I said if W is a test statistic, the p-value or attained significance level, okay, is the smallest level of significance for which the observed data indicate that the non-hypothesis is rejected. So, which means p-value is a measure of the level of significance. And that p-value is now going to be the smallest level alpha can be before the non-hypothesis can be rejected. Does that make sense? And, the takeaway is just going to be, okay, you know what? When I compute my p-value, if the p-value is less than the level of significance, then the non-hypothesis should be rejected. We only want to identify the minimum value of the level of significance to be able to reject the non-hypothesis. Rejecting the non-hypothesis indicates significance, not just significance, statistical significance. Okay? Now, I actually want to walk you through now, okay, how do we compute p-value? Okay, now the other time, if you take a look at what I have here, okay, Uh, you know, and if you take a look at that picture, that graphical representation, when alpha equal to that, when alpha equal to this, we can get different value for the critical score. I show you the other time when the level of significance go down, the critical value actually goes up. Does that make sense? That's what that guy indicate. But you know what? What am I looking for? I actually look at, let's say for, the other time we got this guy. Give me 1 second. We got this guy here to be negative 2.5. And we don't want to use critical score to decide. We want to use a p-value. Okay, if we want to use a p-value now, we got a negative 2.5. If we want to use a p-value now, okay, now we need the smallest rejection region. What is the smallest rejection region? Okay, to reject H naught based on the based on the test statistic value. The test statistic value was negative 2.5. Because why am I looking for that region? Because I need the total area under that region. The area, the area is going to give me the probability. Okay, now if for negative 2.5, and if for a two-to test, okay, mathematically speaking, it's going to go from negative infinity to negative 2.5 union. Union in mathematics, right? Union. Then 2.5 to infinity, because you know what? I'm talking about two-sided. Talking about two-sided, to the left is going to be negative 2.5. To the right, it's going to be positive 2.5. Does that make sense now? Okay. Now, and let me tell you this. Within negative 2.5 and 2.5, within, in the middle, that will be acceptance region. Why the rejection region is going to be outside that. Okay. Now, what I'm going to do now, and now if this guy is an event, then I need the probability. I need the probability of that event. The probability that your Z will lie in between that. And that probability is alpha cap. There's a difference between alpha and alpha cap. Alpha cap is the p-value. Alpha is the level of significance that we call the probability, the maximum probability of committing type 1 error. Now that guy is going to be equal to alpha cap. And let me tell you, mathematically speaking, negative 2.5, mathematically speaking, I actually want to find the probability of the absolute value of Z greater or equal to 2.5. Of course, when you have an absolute value of Z, okay, what you have in the absolute value could be negative or positive. Does that make sense? Now, if we want to do this, what we're going to do is this. This guy here can also be interpreted as this guy. If I want to remove the absolute value, don't forget, to the left of that negative 2.5, to the right 2.5, they're going to be the same area. If they are the same area, I need the two area. I want to add them together. That will be 2 times 1 of that, right? 2 times Z greater than 2.5. You know what you're going to do? Because I'm saying 2 times that. We're talking about 2 tail. Now, you know what you're going to do? Or what you just need to... You want to ask a question? Oh, okay. Now, all what you just need to do is to use your statistical table. Okay? Check 2.5. Okay? And if you check 2.5, your statistical table is for less than, then you're going to do 1 minus whatever you check for before you multiply by 2. But if you want to use R, okay, that is going to be P norm into 1 minus 2.5. 1 minus P norm of 2.5. It's going to be 1 minus, in R, 1 minus P norm. Okay, 1 minus P norm, okay, of 2.5. If it is less than, it's just going to be P norm. of that particular value. Now you're going to do 1 minus P norm of 2.5. Whatever you get, you multiply by 2. That will give you 0.0124. Is 0.0124 now is my alpha cap, which is my p-value. Okay, what am I talking about? That is the probability of observing an extreme value when the null hypothesis is true. Then I'm going to compare the alpha cap that we call p-value with alpha. What is alpha? Alpha is the level of significance, also called level of statistical error, also called the maximum probability of committing type 1 error. Now, this is going to be the rule. Now, we actually, got to 0.0125, okay? And if you get it 0.0125, if you take 0.0124, if your level of significance is 0.05, okay, if the p-value is less than the level of significance, we reject H naught. The null hypothesis is always rejected when the p-value is less than the given level of significance. I told you the p-value is alpha cap, the level of significance is alpha, and if p-value is greater, then it means we're going to fail to reject the null hypothesis. Now, how do we verify? Oh, somebody chats with me right now. Let me see. Yeah, it's for 2 theta's. Okay, it's for 2 theta's. Now, verify that alpha cap satisfies the definition of p-value. How do I know? Okay, I need you to pay attention now. Okay, how do I know alpha cap actually, satisfy? Okay, now I need you to take a look at this. If alpha is greater or equal to alpha cap, in other words, what do I mean? Alpha cap less or equal to. Does that mean alpha cap less? Then the Z alpha over 2 will be less or equal to Z alpha cap over 2. And that would mean the H naught should be rejected. But what if in a situation where the opposite, the complement of that happen? The complement of that is when the type 1 error now, okay, is when the level of significance, which is the maximum probability of committing type 1 error is now less than the p-value. If I want to start from the p-value, it means p-value greater. Of course, that is going to happen, and we're going to fail to reject. Therefore, the smallest level of significance for which H naught is rejected is alpha cap. And that was why I told you the other time we're looking for the smallest. The p-value is the smallest level of significance for which the null hypothesis should be rejected. Now, let us move away from Z equal to negative 2.5. If we assume Z is now 2.0, let's say your test statistic value is 2.0, okay? And you calculate this, right? And you multiply by 2, and that gives you this, okay? Now we can take a decision comparing that p-value, this guy here, okay? This guy here is an alpha cap. Okay, I told you a p-value, okay, let me write that. Oh, okay, let me just say this guy. Okay, that's an alpha cap. Okay, at 0.05 is 0.0456. Is less than that. Yes, reject. That is what that yes means. Because 0.0456 is greater when the p-value is greater than alpha, we're going to fail to reject. That's why you see no, no. Any question? Okay. Now, this, what I'm trying to say now, we're looking at the deviation of the test statistic to the H naught. If there's a huge deviation is significant, then that will indicate small p-value. You see that? That will indicate small value. You know, when p-value is very, very small, okay, that will imply significance in a way. And the evidence against H naught will go up. Okay. Now, what is the summary? Before today, we're using this to take a decision. Before today. Okay. When test statistic lies in the rejection region, you reject H naught at any given level of alpha. And when it does not fall in the rejection region, you fail to reject. That was the way we were taking decision before today. But today, following this lecture, okay, we're actually going to be using this, which means we need to first have our data. After having our data, we get a test statistic. Then we now get a p-value. Let me tell you this. You may not be able to get p-value without the test statistic. And if you want to get your p-value, you need to put into consideration the nature of your test. So what determines the sign in the p-value? Like if my p-value is going to be something greater, is it going to be z greater or z less than, or absolute value of z greater? That depends on the nature of the alternative. Does that make sense? So if you want to figure out the p-value, the other time we said the p-value is the probability of the absolute value greater than the test statistic. Absolute value greater than the test statistic, it means the alternative is two-sided. If the alternative is one-sided, it's just going to be the probability of z greater than the test statistic. If the alternative is less than, that's just going to be the probability of z less than the test statistic. Now, the general method for computing p-value. That is what I just, now in the general method of computing p-value, you need to put into consideration your test statistic value. Okay, now let's say you got a rejection region. You know, we want to reject H naught in favor of the alternative for large value of W, because when the value of your test statistic is very high, you know what I mean? That's actually to, confirm the deviation of the observed data, from the non-hypothesis. And in that case, your rejection region will be W greater or equal to K. Okay? And if I want to get the p-value associated with that, it's going to be the probability of W greater or equal to W0 given H naught. Why am I saying greater or equal to? Because the rejection region here is greater or equal to. Now, that is case one. For case two, at times, we may actually be looking for a situation where W, okay, is going to be very small. When the test statistic is very small, okay, that will favor situation whereby the deviation between the observed data and the non-hypothesis is not much. Okay, in that situation, I'm going to use W less or equal to K, and the p-value is actually going to be this if I want to compute that. Okay, now I'm going to walk you through an example now. Let's say, for instance, we are actually testing a hypothesis, and it is an upper T-tails. Why do I call this upper T-tails? The alternative is greater than, right? Now, my rejection region is going to be greater or equal. You know that? Given alpha, because I told you there's going to be an agreement between rejection region and your alternative hypothesis. Now, you're actually going to see that this is going to, here you're going to apply case one. You know, in case one, we want the W to be able to reject the non-hypothesis. We want the W to be very large. We want the test statistic to be very large. Okay. Now here, don't forget, these are upper T tests. Before the non-hypothesis can be rejected, your test statistic have to be very large. When your test statistic is very large, that is actually going to be moving towards the alternative. Now, take a look at this. This is how I'm going to get my p-value. The probability of z greater or equal to observe the given h naught is true. And of course, rejecting non-hypothesis or not, or what I'm going to do is to compare the p-value with the level of significance. When p-value is less than the level of significance, the non-hypothesis is rejected. And when the p-value is actually greater, then we're going to fail to reject that. So this is for one tail and upper tail test. What about lower tail test? The lower tail test here we actually favor what? Your rejection is going to favor very small value for test statistic for you to be able to go for the alternative. Does that make sense? Okay. Now, and the rejection region is going to be z less or equal to negative z alpha. Don't forget when you're going when you're considering the lower tail tails, it's going to be negative z alpha. Why is it that I didn't write z alpha over 2? This is a one tail test. Okay. And here, if I want to get a p-value, I'm going to apply case 2. Don't forget the case 2 is the one that supports when the test statistic is small. Okay. Which is going to be this guy here. That's what I'm doing. And the same decision, whether lower tail test or upper tail test or two tail test, when the p-value, when p-value is less than the level of significance, the non-hypothesis will be rejected. Is there any question before I move forward? Is there any question before I move forward? Am I talking so fast or so slow, or is there anyone in this class that is struggling getting the way I talk? Is there anyone? Okay. Now, what about two-tail test? Of course, for the two-tail test, the rejection region is going to be that guy. Don't forget absolute value greater or equal to z alpha over 2. Now, in that case, I'm actually, my p-value, if I want to get that, is going to be absolute value of that greater or equal to the absolute value of the observed z, given that the non-hypothesis is true. And of course, z is standard normal variable. Is going to be follow normal distribution with the mean zero variance 1. And at the end of the day, all what I'm going to do, when I find the probability of z greater, which is going to be 1 minus whatever you check from the z table, then you multiply that by 2. That will give you your p-value. Okay? Now, the same decision. Now, I want to summarize. You could have any of these tests. Whether a two-tail test, how do you get the p-value? Okay? For two-tail test, this is how to get the p-value. And what determines how to compute the p-value between the non-hypothesis and the alternative is the alternative. Does that make sense? How do I compute? You can see here, this is the non-hypothesis. My non-hypothesis could be against a two-sided alternative, could be against upper tail, it could be against the lower tail test. But I needed to see that what we put into consideration in computing the p-value was the sign, inequality sign in the alternative. Take a look at that. The inequality sign in the alternative actually going to be the sign that we're going to put into consideration if you want to compute the p-value. Okay. Now let's look at an example now. I want to walk you through example on proportion. Okay, we've been working on the mean, difference of means. Perhaps we could also have an hypothetical statement about proportion. Now, a machine in a factory must be repaired if it produces more than 10% of defectives among the large lot of items that it produces in a day. You know, we solved this problem before, right? Okay. A random sample of 100 items from the day's production contain 15 defective. And because 15% is more than 10%, you know, the manager here believe that the supervisor believe machine should be repaired. You know, the supervisor did not behave like a statistician. You know, if I want to know whether there's a significant difference between two numbers, what I need to do is to conduct a standard statistical test, not just merely looking at the numbers. Now, the hypothesis under investigation now is going to be 1-2 because the man believe the percentage of defective is more. Now, of course, if you want to do that, we know that that is going to follow binomial distribution. And of course, I've walked you through that. Okay, and you try to find the Z statistic, and that's actually give you 1.667. You know, the alternative way, what we did the other time is to also obtain a critical score, given level of significance, and compare the test statistic with the critical score. If the test statistics is greater than the critical score, we're actually going to reject, but we don't want to go that way. We actually want to use the p-value. Using the p-value now, it means I want to find the probability of Z greater than Z given H naught. So which means the probability of Z greater than the critical score, which means I'm just going to go to normal table. Okay, whatever I check from the normal table, I'm going to subtract from 1. Or you do 1 minus p norm of that, and that give you a p-value of 0.0475. Okay, now the level of significance given here is actually 0.01. And the only condition to reject the null hypothesis is when the p-value is less than that. But the 0.0475 now is greater than that. So which means we're actually going to fail, okay, to reject, okay, the non-hypothesis. So like I said, if alpha less than is 0.475. Alpha less than is 0.475 means alpha is 0.475 greater than alpha. Okay, so it's 0.475 is the p-value. When p-value is less than the alpha, the p-value here is less than alpha. Oh, sorry, it's greater than alpha. It's 0. Sorry, let me see. Yeah, it's 0.01. And it's 0.0475. It's 0.0475 is greater than 0.01. So we're going to fail to reject. So failing to reject means, okay, there is no statistical significant difference between 10% and 50%. So the supervisor decision was wrong. Now I want to go into the last example. You remember the other time when a politician claimed that he won maybe because of the plurality decision, okay? And because of that, we want to test hypothesis, okay? The minimum required for majority to, win election is 50%. Alternative is going to be less than that. But we choose a sample of 15 voters where we're going to ask them. But when we ask them question, we needed a rejection region. Okay, let's say the rejection region was y equal to 3. Okay, if we're in the sample, if you're able to get 3 people that say I did not vote for the person, then I'm actually going to reject the non-hypothesis. Rejecting the non-hypothesis, then it means that okay, that guy is likely to receive less than 50% of votes. But let me tell you this. before you can use the knowledge of normal approximation, because if you want to carry out study, we have been using the idea of a Z, a standard normal distribution where we're checking from the normal table, and according to the MOVA 1733, when he discussed the approximation to binomial, he gave a condition. That condition is not satisfied here because the sample size is less than 30. If you want to go by central limit theorem, okay, it's less than 30. And because of that, we are not going to use the idea of a z-score. We're actually going to use the binomial distribution itself. Okay, now using the binomial distribution, of course, if I want to study this, I need a test statistic, which is going to be y, which that very y would be the number of people that actually said they vote for the guy out of 15. Now we're going to set a rejection region. The rejection, if the number of that is less or equal to a particular value, then I'm going to reject the non-hypothesis. Now, because of that, we're actually going to be using case 2. Why do we want to use case 2? The case 2 is going to be talking about small value of test statistic. Because to reject, because the non-hypothesis, take a look at the alternative here. Less than means the value, before I will go for that alternative hypothesis, the test statistic value has to be small. Okay? Now that is why I'm using case 2. Now, I now need to figure out my p-value now is going to be, what is the probability of y less or equal to 3 if your k is 3, given that the null hypothesis is true. Okay, given the null hypothesis, don't forget the distribution is binomial. Null hypothesis is true. We're using p to be 0.5, n equal to 15. If you want to go by, or you can check a binomial table, okay, for 3, n equal to 15, p equal to 0.5, that will give you a p-value of 0.018. Now, we're going to compare. We can decide to choose a reasonable level of significance. I'm actually going to compare this guy now with level, like with 0.05. What happened is 0.018 is less than 0.05. I'm going to reject. If the level of significance is 0.02, that is still less, I'm going to reject. But if the level of significance is 0.01, the p-value is greater than that, I'm actually going to fail to reject. Okay, take a look at that. Now, what if a question now has, here, the minimum value to reject, okay, was when k equal to 3. Okay, now let us now investigate. Okay, let's say, for instance, find the rejection region such that the level of significance is 0.05. So in that case, I don't know the values of k, but the level of significance is 0.05. Since I don't know the values of k, I can decide to go from 0. Okay, I'm going to start from 0 until I actually come across a value that will be less than 0.05. Okay, you can use binomial cumulative, where k is 0, that is that, where k is 1, where k is 2, where k is 3. You see that? Now, if you take a look at all of this, the p-value is actually small, but we're looking for, like after this one now, what is the next? When you go to k equal to 4, that will be greater than 0.05. And that is why we're stopping at k equal to 3. And that was why we said that. And that was why I said to control type 1 error, I said now, this one mean now, not no. Now, sorry about that, my W is here. Now, okay, the rejection of the format, y less or equal to k, can be found such that level of significance is 5%. To control type 1 error rate at most 0.05, Okay, we use rejection region y less or equal to 3, the largest rejection region such that happened. If you take a look at this, okay, this is going to be the largest of all of these. That is less than 0.05. And after that, the next value that you're going to get when you go for k equal to 4 is going to be higher than the level of significance. This is where I will stop today. Before I go, the lecture of Monday, I splitted it into 2 videos. Okay, and it's already on YouTube. Okay, you know, the first one was probability of type 2 error for z-test. And the other one is a relationship between hypothesis testing procedure and confidence interval. So this video is also going to be published tonight. Okay, make sure you stay safe and have a lovely day. See you on Friday.